arc length and sector area are easier to work out using radians than degrees. You may remember from your GCSE the formula for working out the arc length as being the fraction of the circle you have, theta over 360 times 2 pi r. So you're always dealing with this awkward ratio here. But when we move over to radians, because of the definition of the radian, the formula is much simpler. It's just L equals r theta. No awkward conversion factors. They're actually the conversion factors to convert from degrees to radians. Let's just check though that this formula looks correct. In the simple case where theta is 2 pi, which remember 2 pi, 360 degrees, it's a whole circle. So for the whole circle, what is the arc length? We put theta equals 2 pi into r theta, and we get the arc length to be 2 pi r, the circumference of the circle, as we should expect. Let's now try a simple example. If we are given both the radius of the circle and the angle that the arc is making, we work out the arc length by multiplying the two together. We just work out r theta, and we end up with 7.2 centimeters, very straightforwardly. Let's go on to a slightly more awkward example. In this case, we're told what the arc length is and what the radius is, and we have to work out the angle. So we're going to use the same formula, L equals r theta, but we're going to rearrange it so theta is the subject. Okay, let's just see what this diagram looks like. There we are, 5.4 and 9. Remember the diagrams, not to scale. Okay, so we can use L equals r theta. Well, we can put the numbers in first. Then we can rearrange it to make theta the subject, and we quickly get the answer 0.6. Now notice it's just 0.6. There's no units or anything we put on, and the implication is radians. We obviously wouldn't put degrees on because we're in radians, nor do we put a pi in, which some people sometimes do, because that would be saying we're multiplying the 0.6 by 3.14, etc. Okay, and so no, we just leave it as this. If you really want to put units in, write the word radians in, but it's not necessary. Okay, how about sector area? Well, you'll remember from GCSE, it was the fraction of the area of the circle you had, so it's theta over 360 times pi r squared, but now it's rather simpler. The area is now a half r squared theta. People do sometimes forget the half. It's very important, and again, when theta is 2 pi, so the whole circle, then we get the answer we should expect. The area is pi r squared, and so that half is needed to cancel out that 2. Again, we'll start with the simple example of the same values. What's the area? Well, we put 6 and 1.2 in for r and theta into the formula. Okay, so we get a half of 6 squared times 1.2, so the area is 21.6 centimeters squared. Here's a slightly more awkward case. Okay, here we have given the area of the sector and the angle. What's the value of r? Okay, again, we've got to make r the subject of this equation. Okay, the area is 22.5. We put the values into our formula. Okay, 22.5 equals a half r squared times 0.8. Can simplify the right-hand side, divide through, and surprise, surprise, we have one where we get the answer is exactly 7.5 centimeters, so no need to approximate it. Okay, here's a past paper question, not too difficult, on working out perimeters and areas of shaded regions. So they, as with most exam questions, they've given you all the information in words and some of it shown on the diagram. Okay, the lengths aren't shown on the diagram. Okay, so first of all, for this shaded region, we have to work out the perimeter, and for that we see we've got 2 arcs, one from A to B and one from C to D, and also these 2 remnants of the radii to work out. So I'm going to work out the areas of the arc, so that's L equals r theta. So for instance, for A to B, that's where we work that out, where the radius is 20 and the angle is 1.8 radians. Similarly, we can work out C to D as being 15 times 1.8 radians, the angle is still the same. We work out the two differences here are each 5. We add everything up to get our answer of 73 centimetres. Okay, so we can do that one straightforwardly, the perimeter. The next part of the question was to find the area of the shaded region. Okay, how are we going to be able to do that? Well, what we need to do is work out the area of the sector OAB, the whole bit, and then we move the area of the unshaded part. Okay, so we consider it as two sectors, a bigger sector and a smaller sector. We work out the area of the biggest sector and subtract then the area of the smaller sector. Area of the sector, of course, given by half r squared theta. So we work out the area of the big sector. That's a half of 20 squared times 1.8. And then we work out the area of the smaller sector, a half of 15 squared times 1.8. We subtract and we get our final answer, 157.5 centimetres squared. There we are. Hopefully now you can enjoy working out the areas of sectors and the length of arcs, because working in radians is much easier than it is working in degrees. Thank you for watching the video.